here's similar figures again. This time we're on page 7 of our notes. And our main goal here is to solve for missing sides of similar figures. And so instead of declaring whether they are similar or not, we are actually being told these shapes are similar. And we're going to use that information to help us solve for a side that we don't know. So let's go ahead and look at problem 7. I know I skipped the top 2 numbers on this page. I'd like you to try those on your own, and then I'll just quickly give you the answers when I'm done with doing these other 3 problems. Okay, so we have 2 similar triangles. I'm assuming the 12 goes with the 3 and the 20 goes with the x, and I'm just basing that on appearance, which is a little risky. You shouldn't always just base problems like this on the appearance of the triangles being similar, but that's what we're going to do in this case. So, because it does say they are similar, so if this is also drawn somewhat correct, then they would be lined up properly for the sides to correspond. So I'm going to take my 12 over 3. If you'd rather, you could do 12 over 20. I'm hearing 12 over 3 equals 20 over x. So I'm going big triangle, little triangle, big triangle, little triangle. So we have to make sure our ratios are set up exactly the same way. You don't want to do big triangle over little triangle and then little triangle over big triangle, or you'll get the wrong answer. You have to do it the same way both times. So I mentioned we could also have done 12 over 20, but then we would have to say that equals 3 over x, because 12 goes with 3 and 20 goes with x. So they just have to line up properly. Now we're just going to use what we've been learning about ratios and proportions, and we're going to cross multiply. So cross multiply, we get 12 times x and 3 times 20. And then all we have to do is divide 60 by 12, because we're going to divide that 12 from both sides. And that will give us x equals 5. There, we were able to solve for the length of something by using similar figures. Let's do this one. So we've got a rectangle and another rectangle. We know the length and the width of this rectangle, but we don't know the length of this one, even though we do know the width. Okay, so we are going to set up our ratios. This time, just for fun, I'm going to stay each ratio within the same shape. So instead of doing 7.5 over x, because those two do go together, they're both the lengths, and then 4 over 3.2, I'm just going to do 7.5 over 4, so both are sides in the same shape, and then I'll do the corresponding sides in the other shape. So the 7.5 corresponds to the x, so those are both going to be in the numerator, and then the 4 corresponds to the 3.2. So it doesn't matter if you set it up like we did with this one, where we take a length from one shape to the other shape, or if you set it up like we did with this one, with both of our lengths being in the same shape. It's still actually going to give you the same answer. If you don't believe me, you can try it both ways. So cross multiplying again, I get 4x equals, now I want to use a calculator for this one, 7.5 times 3.2, which is 24. And now all I have to do is divide both sides by 4, and I get x equals 6. So I found the length of the side of this rectangle simply because these rectangles are similar. Okay, now we're going to do number 9, but number 9 is especially tricky here because we have 2 different things to find. We have y and we have x. So I'm going to go ahead and start with finding side x. It looks to me like, based on the angles that are congruent and things, that side x goes with 9, don't you think? So x goes with 9. And then we can't use y, even though it goes with 12, because then we'll have 2 variables in the same problem. We don't want to have 2 variables in the same problem. We need to use a couple of numbers that aren't variables. So x goes with 9, but we also have that 4 goes with 6 and 12 goes with 18, in addition to the fact that y goes with 12. So we can use the 4 over 6 or the 12 over 18. I think the smaller numbers would be easier to work with. So x over 9, because those are corresponding, equals 4 over 6, because those are corresponding. So there I get my problem, and now I can cross multiply 6x equals 36. Divide both sides by 6, and x will equal 6. Okay, we're not done until we find y. Okay, so here's y, and y goes with 12. But we can still use the 4 over 6. If we'd rather, we can use the 12 and 18. It just is bigger numbers to work with, but it should be the same ratio. Because 4/6 reduces to 2/3, and 12/18 reduces to 2/3. So we could honestly just use 2/3 if we wanted to. I'm going to go ahead and use 4/6, just like I did in the last problem. So I have to do these separately, one problem for x, one problem for y, but I can use the 4/6 ratio in each problem. So cross multiply, we get 6y equals 48. Divide both sides by 6, y will equal 8. So we have this side with a length of 8 and this side with a length of 6. We found the missing pieces because the two shapes are similar. Alright, this gets more tricky sometimes when we have triangles that are overlapping. If it helps, you can honestly draw out your shapes separately. So let me just show you, and I of course have the advantage of my tools here. So if I kind of trace over that triangle, then those three sides can make that triangle. Group those together. So there's one triangle, right? And then I could do, let's pick a different color. We could do this other triangle. Oh, I didn't mean to pick one with an arrow on it. Ah, well, not a big deal. So there's our bigger triangle. Select all my sides, group them together, and move that over there. So now I can see easier the two triangles that are overlapping, and I can label them separately. And then my problem will be more like the ones I've been used to doing already. Now, if you don't need to draw them out separately and you can figure out what you're doing without doing that, then by all means, go for it. You're good. So you can see this little triangle here has a 2 here and a 5 here. Obviously not drawn to scale because the 2 and the 5 look about the same length, but 5 would be more than twice the length of 2. So your pictures don't have to be exactly right in order to do the problem. Then our big triangle, this side is a length of 8. I don't like the way that this blue line is longer than DK. It's misleading. But I'm pretty sure that's what it's trying to say, is that this side of our triangle from D to K is a length of 8. So we want to find the distance from D to N. If you'd like, you can even label your triangles with the correct letters. I don't think it's necessary because we know that the way these were nested together, the triangles can just be this way because these are the congruent angles, and so I think we're good to go. Let's go ahead and do our ratios. So we can do 2 over 5 equals 8 over x, or we could do 2 over 8 equals 5 over x. It doesn't matter. We'll get the same answer either way. And then that way we have cross multiply 2 times x and 5 times 8, which gives us 40 divided by 2, which is a length of 20 for side x. Okay, as promised, I'm going to just go back really fast to questions, I think it was 5 and 6, just to give you the answers for those, just so you can check your work. And meanwhile, here's how we use similar figures to solve stuff that we don't already know. And that comes in handy when we do what we call indirect measurements or scale drawings. We're going to look at those next. Okay, quickly looking at number 5, we have this rhombus and another rhombus that's been turned the other direction. But this rhombus shows these two angles congruent to those two angles, and these two angles are congruent to those two angles, and these sides are all the same, and these sides are all the same. So the ratios of 4.5 to 3 are going to be the same. 4.5 over 3, 4.5 over 3, 4.5 over 3. That's going to be the ratio. So if you're not sure what that ratio is, you just use a calculator to divide it, or look, to get rid of this decimal, this 4.5, I could actually multiply it by 2. You know how you can divide the top and the bottom of a fraction by a number? You can also multiply the top and the bottom of a fraction by a number, which is handy to get rid of decimals sometimes. So I'm going to multiply by 2 and multiply by 2. That would change this to 9 over 6. Now that's going to be a lot easier to reduce into 3 halves. So the ratio, the scale factor for problem 5 is 3 halves. Okay, so scale factor. And then we just need a similarity statement. So these aren't triangles, so I'm not going to draw a triangle. I'm just going to name them. So let's see, RSTU is going to be similar, and resist the urge to just go alphabetically, which is what I did on this one, because they may not match up. Like if I go alphabetically, it would be MNOP. But M doesn't go with R, because R is a bigger angle than M is. So I either need to start with N or I need to start with P. It doesn't really matter. Pick one. So P is the same as R, and then M can go with S, because it's got the double angle. And then N can go with T, and then O can go with U. So just to make sure you're being careful to match up congruent angles when you do your similarity statement. Okay, last one, number 6. So let's just look at our ratios. We've got one rectangle and another rectangle, and this rectangle's been turned. I'm going to turn it around the other way so I'm less confused. So this is 15 by 10, but I'm just going to switch it so it's 10 by 15. Now I can see a little easier what goes with what, right? And since this is a rectangle, both of the sides would be 10, both of these sides would be 15. Both of these would be 20, both of these would be 15. So now hopefully we can match these up to do our similarity ratio. So the 10s over here would go with the 15s over here, so 10 15ths, which reduces to 2/3. And then the 15s here would go with the 20 over there. So 15 goes with 20, and that would reduce to 3/4. Hey, 2/3 is not equal to 3/4. So that means that these are not similar, even though they are both rectangles. That does not automatically make them similar.